includes gas molecules, I believe it is not empty. Gas molecules are weakly bound together because they have little attraction to one another. When compared to a particle in a solid or liquid, they are far apart and constantly moving. When the particles collide, they don't interact with one another. Instead, they just hit and bounce off of one another. Gases are also too tiny to be seen with the naked eye. Gas molecules from the bottle were driven into the balloon expands as you squeeze the bottle. Because the majority of a gas volume is made up of enormous quantities of space between the gas particles, a gas molecule is compressible. A gas will not only conform to the shape of the container it is in, but it will also expand to fill it. As gases do not have a constant volume, they respond to pressure fluctuations by changing their volume. Individual gas molecules constantly bounce off the container walls in a closed gas-filled container. When the gas molecules collide with a wall, it exerts a force on that wall. The force of molecules hitting the balloon walls maintains the balloon inflated in a flexible container like a balloon. When you compress the liquid-filled bottle, you are reducing the volume of the bottle container. Squeezing the bottle causes it to deform into a shape with a low volume to surface area ratio. The ratio is now lower than before. The liquid will flow into the balloon because the bottle is now crumpled and there is more room for them to squeeze in. The volume of the liquid does not change, but the volume of the container changes. Because the container can't hold all of the liquid, it spills out. The particles in a liquid are attracted to one another, but not as strongly as they are in a solid. A liquid particles are close together, constantly moving, and can slide past one another. We couldn't squeeze the water-filled bottle as tightly as we could when the bottle was empty because there is no much room between the gas molecules. Gas compresses more easily than solids or liquids. Particles of a solid are very close together. Because the forces between the particles are so intense, the particles can only vibrate and not move freely. A solid becomes a stable, non-compressible shape with a defined volume as a result of this. Sand is a solid, but it has a fluid quality about it. Because its small particles takes the shape of the container you pour it into. It behaves like a liquid. Solids have small interparticle spaces and are densely packed, so they cannot be compressed because there is no room for the particles to move. However, gases are not densely packed, so their particles can move around freely, making them highly compressible.
Gas molecules are well separated with no regular arrangement. It vibrates and moves freely at high speed, while liquid molecules vibrate, move about, slide past each other, and are closer together with no regular arrangement. The atoms and molecules in gases are much more spread out than liquids. They vibrate and move freely at high speeds. This means that they will move to fit in any space, making it easier to squeeze. But in liquids, the particles roll past each other and still slightly pack, making it less easier to squeeze than.
Good day everyone! I am Malones from SCIED Sciences 3. In this video, I will be performing the part 2 of this activity. A molecule is a particle of matter and the smallest unit of a substance. The actual average speed of molecules depend on their mass and temperature. And in this video, I will be showing you how the temperature affects the molecular speed. And here are the materials. We have 2 plastic cups filled with hot water and cold water. We have 2 food colorings, the color blue and the color yellow, with 2 droppers.
Using droppers, carefully place 1 drop of yellow and blue food coloring into hot and cold water, respectively at the same time. Remember, do not mix the water using any materials. Allow the colors to mix on their own.
As we have observed in the activity, the molecules in warm water move faster than molecules in cold water. The rate at which colors mix in hot and cold water indicates that molecular speed is directly proportional with temperature. Warm water has more energy than cold water, which means that warm water molecules move quicker than cold water. The food colorings that I added to the hot water were pushed with water molecules in a faster rate, simply because the higher the temperature, the faster the molecules moves. That would be all, and thank you so much for watching. I hope you have learned something. And always remember, seek the simplest explanation of a complex fact.